In this video, we are going to see an example of how to use the built-in debugger in Visual Studio to help us when we are having some type of error in our program and we just absolutely cannot figure out what it is. Now, I'm a big fan of trying to put things into your code to make it easier to debug and somewhat trying to debug yourself. But every now and again, when you're totally stuck, the debugger is this really great tool for stepping through your code literally line by line as it is executed. And so if you're really and truly stuck, if you're using the debugger and you're stepping through one line at a time, you absolutely should be able to find where things are going wrong. So for this example, I am using our RSA project that we've done in class, where we are taking messages and encoding them using the RSA cryptosystem and then trying to decrypt them. So we're sending and receiving messages. Ideally, in RSA, somebody would send you a message using your modulus, your modulus and your public encryption key, and then it would be a task for your class to decode the message that is sent to you. Because I'm just me today, I'm sending myself a message and decrypting that own message, the same message, which is somewhat silly, but we're going to have to just go with it for today. So what's going on here in the code? We're using our RSA cryptosystem, which means we have two primes that we're going to put together to create our modulus. And so we create the two primes, integer prime 1 and prime 2, and we pass those to an RSA object that we've defined in our own header file here, which is called mycode. So what does our object do? Our class has two different primes. It has a modulus, a public encryption key, a decryption key, which is private. It's got this totient number that we need in order to decrypt things. And then it's got a whole bunch of different functions. So here's our constructor where we take in two primes, which we just called P and Q, and we create all of this information from there. And then we have all of these getter functions, when in fact this shouldn't really be there. We shouldn't really give away that private information, but we can give away the modulus, we can give away the encryption key, and we can decode something that's sent to us. So if we are sent, remember in RSA, we take the letters of the alphabet and we associate numbers to them, normally in a standard way. A goes to 0, B goes to 1, C goes to 2, and so on. We create numbers out of that, and then we perform this RSA algorithm. We take those numbers and we raise them to the power of the public encryption key, and we look at the answer modulo our modulus. Here, that's the name. And that's how we encrypt a message. And then our class's job is to be able to decode those things. So when we get a message, it's just a big long collection of numbers. That's what we're going to be given, our vector of integers numbered words. And then we need to somehow translate that back to a string. So what we do is we raise that message to the power of our private key and look at the answer modulo that, and what we should end up with after we've done that process is a bunch of numbers that came from letters, so numbers in this range of like 0 to 26, and then we just translate those back to the letters that they came from. So that's the other piece of information that we're passing to our decode string function. So we're passing with this array of characters. So the position at the array is the number, and the character at that position is the letter that we should think of as corresponding to that number. So at position 0, we have the letter A, at position 1, we have the letter B, and so on. And our class should be able to decode a message that's been sent to us. So that's what's going on here. And back in main, we have these two primes. We pass it to mycode, and then we would tell the world the information that they need to send us a message, which would be the modulus and the public encryption key. Internally then, we have these things that we're going to need. We have this map, which is letters to numbers, which takes the letters that might appear in our string and gives them a number. And then we have the reverse. We have something that takes in a number in that range of 0 to 26 and spits out the letter that it should correspond to. So we have both directions, one direction for encoding messages and one direction for decoding messages. And this is what we want to do with that. We would want somebody else in the world, ideally somebody else, to be able to take a string, which is their message. Here we say hello world, and then encode that message. So they call this public function that's not part of the class but exists here in main or would exist on their computer, which translates their message according to this map, letters to numbers, with what values. It needs to know how to encode it, so it needs my encryption, my public encryption key, and it needs my modulus. So we'd send all those things to the toNumbers function, and it will take our string and encode it as a collection of numbers. And once we have that collection of numbers, that's what would be sent to us on our computer. Our computer and our class object would have the job of decoding that message and figuring out what it was that person 1 wanted to send us. What was their original message? So what we do is we take our code and we call this decode string function. We pass it this collection of integers and the way we're going to translate numbers to letters. And we're going to get a new message out of that, which, if there's any justice in the world, our new message will match the message that was sent. That's the point of RSA, is we're supposed to be able to recover that original message. So now we know what the message being sent is. It's hello world. And we have this other string, new message, which we don't know what it is, so we'll have to ask it to print us out to the screen. What does my class think that the message was that was sent to me? And let's go ahead and let's run that. Right, I commented that out and I probably shouldn't have. So let's just go back and let's not mess with anything. I shouldn't really have that function at all, but for now, let's just go ahead and leave it there. Let's go back and run things and everything should work. Okay. So it tells me what the modulus is. It tells me what the encryption key is. It tells me something else that I've forgotten to comment out, which was my ASCII character code for this numbers to letters business. And then it just tells us what? It just has a big collection of question marks. It has no idea what that string should be. So something's going wrong, and we're unable to figure out what the message is. So this is a perfect case for the debugger. Of course, I could try a handful of other things, but let's see how we use this with the debugger. Now, up until this point, I should tell you that in theory, I have no idea where the problem is. Maybe it's this toNumbers function that's messing up. It's making a mistake. So I should really check into that and check to see that that's working properly. However, just for the sake of time in this video, I happen to know that the error is not in this toNumbers business, that our toNumbers function is translating hello world properly, and it's this decode string that's messing up. So we know that somehow we're calling this decode string function and it's not able to recover what our message is. So we know that the error has to be somewhere here in our rsa.cpp file when we get to this decode string function. So what does the decode string function do? It starts with this empty string message, empty string, and it goes through one at a time. It steps through this vector of integers number word, and it takes the first number, and it tries to find the letter that it should use for that number. So it stores that as current integer, just kind of peels off that position in the vector, and then it comes up with another integer, which is the decoded integer. So it calls this take modulo power function, take mod power, right, along with this current integer. Goes up to take modulo power and it runs something. It tries to compute what that power should be, reducing as we go so that we hopefully don't have overflow issues. Then it returns that value. So what was the encoded number? And then it tries to figure out from there what the decoded number should be. And then it tries to figure out what the character should be for that decoded number. And notice here that this default is the question mark character. So we have a character decoded letter, which is question mark. And we use this as a little bit of a tester. So we want to check decoded integer. Remember that our character array here only has 27 spots in it, one for each letter of the alphabet and then a space. So if we're going to overstep the bounds of our array, we have some number. As long as this number is greater than -1 and less than 27, we'll be in the array. So if we go to translate at this decoded integer, we won't overstep the bounds of the array. And that's what we would want the decoded letter to actually be. But if something goes wrong and this decoded integer is not in the range of 0 to 27, then our program won't crash and we won't overstep the bounds of the array. We'll just keep the character as a question mark, and this will serve as an indication to us that something has gone wrong. And then very much at the end, we add to whatever the message is, this decoded letter. Just add it on. So we can figure out from taking a look at this code what must be going wrong. We have this character decoded letter, and it must be the case that we're never satisfying the clause of this if statement and ending up changing what the letter should be, because question mark isn't in our translating array. So we're never getting into this if statement, which means something's going wrong with decoded integer. So here's what we do. We know something's going wrong with it. So basically what we want to do is we want to run the program until we reach decoded integer. And then once we reach this part of the program, we're very interested in what's going on and we want to take a further look. So what we're going to do is insert a breakpoint at this point. So we're going to say program run until you reach this point. And once you reach this point, stop running so that I can take a closer look at you. So I'm going to right click here with my mouse, and it gives me a whole bunch of objects, and it says breakpoints. So what I'm going to do is I'm going to say I want to insert a breakpoint right here. This is what I want. And this means when I start the debugger, run the program until you reach this line of code and then stop so that I can see exactly the state of everything when I reach this point. So I go back to main and I say debug, start debugging, which is F5. Mine are all hidden on my computer, so I have to painfully click this every time. But if you learn the shortcuts, this can be very helpful to you. F5, start debugging. The program runs, it flashes my console screen, and then it comes here, and it's got this little arrow that coincides with the breakpoint. It says, I'm right here in the flow of control. And it has not yet executed this line. It got to this line, and then it stopped. So this line, 71 right here, is the last line that actually executed. And if you hover over things, it starts to tell you their value. So I hover over message and it tells me, yes, message is the empty string. I hover over I and it tells me I is 0 right now. I'm on the 0th iteration of this array. It tells me current integer is 155549. And then I look at decoded integer and it's this crazy value, -858993460, which is not at all what we would want it to be. The reason it says that is it hasn't done anything to initialize decoded integer yet. That's whatever garbage value is left inside decoded integer in that spot in memory from the last time it was accessed. So it has yet to execute this line, so there's a garbage value in decoded integer. But decoded integer is something that we're very interested in. So I always have this option to keep running things and just kind of keep hovering over decoded integer. But if I'm particularly interested in decoded integer, what I can do is right click on decoded integer and say add a watch to that. And I'll add it to this box down here, and then decoded integer as I'm debugging will stay right here, and it will constantly update this value. So now my program is stopped, I have some options for what I want to do. My first object is to hit continue. If I hit continue, what will happen in the debugger is the program will start running again instantly, and it will run until it reaches the next breakpoint. I've only added one breakpoint here. It is a breakpoint, however, that I would reach, quite often. So let's go ahead and let's hit continue. I'll hit this breakpoint again because I'm inside this for loop. So for each one of these numbered words, I'm going to go through this process. And so I'm going to hit this decoded integer breakpoint, numbered word dot size number of times. So if I hit continue, what will happen is we'll just run until the next point in time we hit this issue, which is at the next step in the for loop. So we hit continue, nothing happens. But look how everything's updated. So it's telling me that my message is no longer the empty string, it's the string with just one question mark in it. If I hover over I now, it should be 1. So we're on the next iteration of the for loop. Current integer is something new, different from what it was last time. And decoded integer at this point, 519163, is the value that it took after we ran this take modulo power function on I is equal to 0. It's equal to that value because remember we haven't done this line yet. The breakpoint is before the start of this line. So we've yet to start run this line of code, so this must be the output that we had from the last time, 519163, and sure enough, that's not in between 0 and 26. So that's the reason that we were stuck at question mark, because it told us that our decoded integer was 519163. We didn't want to access our array of size 26 at position 519163. So that's what went wrong. We knew it went wrong, but we still have no idea why it went wrong. So continuing to the next breakpoint is just going to show us that one at a time we seem to get these question mark functions. And this value right here, 519163, it's just wrong, and we really have no idea why. So let's try to jump in further. Let's see if we can step into this decoded integer function and see what's going wrong. So if I don't want to continue, I have this ability. I go up to the debug menu, and I have these three things I can do. I can step into, I can step over, or I can step out of different places. So step into and step over are for moving forward in your program, and step out is for if you've accidentally stepped too far, you need to step back. So step over means go to the next line of code as I see it right now. So I'm sitting right here on line 72. Step over would say, now run line 72. Now run this line of code, and stop when you sort of hit line 73. So if I hit debug, step over, it goes ahead and it executes. So it shows me actually that I'm at line 76 because this is all a bunch of comments and white space. It's at line 76. It has yet to execute line 76. So it hasn't done this yet, but it's finished running this take mod power. So it goes to the next line of code as I see it, but that's not literally what the program did. The program changed the value of decoded integer by calling this take mod power function. And so by stepping over, I didn't walk into this take mod power function. I just said, go ahead and run that task, and when you've finished here, move on to the next thing that this current function would execute, which is to go right here. And it's going to set decoded letter equal to question mark. So I've again missed. I now know what decoded integer has changed to 249281. So I know what's going to happen with the rest of this code. It's going to start out by making decoded letter question mark, and then it's not going to get into this if statement, and it's going to make message 2 question marks. So let's see that happens. Let's run till our next breakpoint again. Continue. That's exactly what happens. It's 2 question marks. And we're back at this point. So what we actually want to do, if we want to gain some insight as to what's going wrong, is we're starting to think that maybe the problem is not in this decoded string function at all, but it's actually in this take modulo power function. This seems to be where the issue is. So what we want to do is we want to step into this line of code. We want to go where the computer is going next. We don't want to skip everything that's happening here and move on to the next thing. We know that this is more specifically where the problem is, so we want to step into the computer's eyes as we go into this line. So we say step into at this particular line, and so it says, oh, okay, you want me to go where I went? I went into this function. I actually went up to line 55, and I called this function. So I have this integer. I was sent the integer 296957. Let's add a watch on that number, this integer, which is what I called the function with. And then we have this integer retval. That's something else I want to watch. Right now it has a garbage value in it. It hasn't been initialized yet because we're just standing right here. We've entered the function and we've done nothing yet. Now let's start stepping over. So step into here, go to the next line, enter here, and we're at line 56, have yet to execute it, where we're going to set retval equal to 1. So let's step over and do that. Now this has changed to 1. Red telling me that it's changed. And now I have this nice loop. So decryption number of times, I'm going to loop through, and I'm going to change retval. It's going to be whatever it was multiplied by this integer that was passed to here. But because I don't want any overflow issues, I'm going to mod that by modulus. So we can hover over. I has yet to even be initiated. So let's step over this next line of code. So we've made it through there. And retval is about to get changed. Right now it's 1. But we need to take retval and multiply it by this integer and then mod it. So retval is currently 1. This integer is 296957, and modulus is bigger than that. We'll just add it to our watch point so we have it there. So what should happen after we run this line is that retval should become this integer because it's smaller than our modulus, so there won't be any modding to happen. So let's run that line of code. That's exactly what happens. This integer and retval have the same value because here's modulus. And so we have this line seeming to work properly. So now let's debug, and let's step into, so it goes back again. We go back to this for loop. So it's got this I is equal to, it hasn't run it yet, so I is still equal to 1. So let's step over. So we've gone through this. Now I is equal to 2. So I hover over I and it's equal to 2. And retval has its current value 296957. This integer has the same value, 296957. So it's going to multiply those two numbers together. And then it's going to look at the remainder. That's going to be a number bigger than modulus, so it should replace that with its remainder when we divide by modulus. So let's take a look at that. Let's step over and see how everything changes. Now that's what should happen, but we can see here we've got our problem. Our retval is negative 306614. If we're really modding by something, we should always have a number in between 0 and 1 less than the modulus. Our modulus is 544421. So the thing that should be inside ret value is a number in the range between 0 and 544420. And it's not. We've got a negative number here. So we know that this is precisely where the error occurred, right here. Precisely right here, because we've got this negative value in retval and we shouldn't. We'd have no other way of knowing that. So what happened, let me show you. I'm going to cheat. I'm going to use some really fancy math software. And I've got all these things lined up so I can see what they are. So here's Mathematica. Give it a minute to run and think about things, okay? And what we did is we took, let's make an integer that we call, let's call it retval, which is equal to 29, this integer, 296957 times 296957. That's our integer retval. So let's ask Mathematica, what's retval? And it gives me this number, 88183459,849. That's what this number was. When we took retval and multiplied it by this integer, we got this number, 88183459,849. And then we were supposed to look at the remainder of that when we divided by modulus, and something bad happened. What happened was that this number is too big to be an integer in C++. It's got way too many digits. So what happened was we did this multiplication and we got some number which was bigger than the largest integer that we could possibly see. And so C++ went and it got to that biggest value that it could possibly be, and it said, I need to keep counting from here, and it started to count in a cycle. So it went from the biggest value that was allowable for an integer, and then it went back to the smallest value that was allowable for an integer, which is a negative integer. And then it just started counting up from there, trying to figure out where it should be. So even though we made this function take mod power in order to attempt to avoid overflow issues, we didn't quite avoid overflow issues because we're using integers. When we took these two integers and multiplied them together, we got something that was too big, so it overflowed even in this just one computation of multiplying these two numbers together, and it gave us some incorrect values. Now, unfortunately for our program, what this means is that the fix would be a little bit annoying because we'd have to fix it everywhere. If we want to use our code the way it is, we'd have to start changing all these things to longs or unsigned integers, just depending on how big our numbers are. So that's the problem. Our problem is in this take modulo power function. We're having some overflow issues from all of the numbers being too big. So we can stop debugging now. We've gone into this function. We can go back to main. We know what the problem is. And let's just see, to see if our coding is wrong, let's change our prime numbers. Let's change them to something smaller to see if there's any other problems with our code. So instead of being, let's comment them out. And notice that I have some smaller prime numbers here, much smaller prime numbers, 41 and 31. Let's run our code with these smaller prime numbers and see if our functions actually translate things properly. So run our code with these two new prime numbers now. Oh, here's the problem. So remember this. I didn't remove my breakpoint. So I ran the program and it stopped running because I hit this breakpoint. So what I would want to do is actually say debug, let's stop debugging. I need to remove this breakpoint. So I right click where this is and I could either say delete the breakpoint, so I don't want to stop there anymore. Everything should be okay. That was the only breakpoint I added, so I run the debugger. Tells me the modulus, tells me the encryption, and then it prints out this message, hello world. So this in fact was the only issue, is that we were having overflow issues. If I would have used smaller numbers to avoid overflow issues, then our function actually works. It encodes and decodes properly. But we had no way of knowing that since we were having overflow issues. And that's using the debugger. So there's a handful of things I didn't show you. The step out function, just as an example, let me show you. So let's go back to rsa.cpp, and let's say we wanted to add a breakpoint here where we're looking at the message, saying, I'm really interested in that message. So let's add a breakpoint right here. Say we went back to main.cpp and we started to run things. So it runs until it reaches this point. It's got all the things I'm watching right here. I haven't reached them yet, so it says, oh, all those things are undefined. I don't know what you mean when you want to watch these things. Although it's got my modulus, which is much smaller now, 1271, to prevent overflow issues. And let's say I was right here at string message. This is my breakpoint, and let's say I wanted to go through line by line, but let's say I go up here and I say debug step into right now instead of step over. So step over should go to the next line of the program in the function that I see. Step into goes to where the flow of control literally goes next. So if I hit step into at this point, all of a sudden I'm in some strange place, which is not where I want to be. I'm actually in the string library where it's trying to figure out to construct my string. It's trying to make my string for me. And I don't want to be in here. I know that the problem is not in the string library. I didn't write that, and I'm pretty sure that that's working. So I went one step too far. I stepped into something I don't want to be in, and I don't want to have to go through line by line in this code doing God only knows what, just to return back to where I am. So I go up to my debug mode and I say, ooh, I got here on accident, get me out of here. There's a step out function that takes me back to where I was, right back into my code where I want it to be. And I could say, I didn't mean step into, I meant step over. Go to the next line of code, and it lets you do that. And that's pretty much it for the debugger. I mean, it goes line by line. You have to go line by line to find your errors, but it can help you figure out exactly what is where in your program so that you can catch tricky errors.